refer to the same object in memory.
Dot clear. I removed every element from my A. Why is B also clear? Because they both refer to the same thing, okay? Well, what if I do A equals 1, B equals 2, C equals A? So we have C, A equals, oops, A equals some numbers. We have A, B, C is still 1. Okay. So a subtle little thing, okay? When I work with primitive types will always end up being a copy, okay? But when I deal with more composite structures such as lists, dictionaries, and so forth, your variable names will actually refer to the same thing in memory, okay? So what I've done here is when I did what I did here is when I did A equals 33, whatever, 45, I've now taken my A, which was a variable, and that referred to that original object, which was 1. I now said, A, you're gonna now refer to this thing. I didn't change the original thing that it referred to. I just retargeted what that name refers to, okay? And C, because I didn't change what C referred to, C is unchanged. That sort of makes sense? Okay. So it's a subtle little difference of actually changing the value of something versus changing what something refers to. Okay. So we can copy lists. So if we actually wanted to copy a list, so we can do A equals we have B. Uh-huh.
My question is
Equals 1.
1, 2.
A equals a tuple.
Yeah.
Oh, okay. A.
No, it's a list.
Oh, okay. A equals 1, comma 2. Okay. B. Yeah. So both A and B right now refer to the same object in memory somewhere. Yeah. So I can do B. So I can do B dot append 3.
But if you were to say A is equal to 100, B will be still that.
Yeah. Because what we're actually doing here is we need to be aware, or you should be aware of the subtle difference between taking a variable and reassigning it to refer to something else versus changing the thing that it refers to. Yeah. If we want to get down to technical details, basically all of our names are all of our names just refer to addresses somewhere, okay? And when we do A equals something, B equals something, literally what we're doing is we're taking that name and we're saying, hey, refer to something else completely. So when we do A equals stuff, we're saying, hey, we have a symbol called A, and that's going to refer to stuff, which is going to be something somewhere, okay? Now, if I take that stuff and I change it, A is still going to refer to however that stuff was changed. If that sort of makes sense. If I had a board here, it would be helpful. Okay. Yeah. So basically the idea is every time we have a name, you'll hear me calling them symbols because that's really what they are, is their names. So all names are literally just a reference to an object that exists somewhere in memory, okay? When I evaluate the expression name equals something, what I do there is I don't actually change the object that it referred to before, but I now take that name and I tell that name to refer to something else completely. So if I say A equals 1, that means I've created a number somewhere in memory called that has the value 1, and an A refers to that thing. If I do B equals 1, well, they both happen to refer to they both happen to refer to the number 1. But if I do B equals something else, well, B then refers to something else. Have I confused people or have I made things more clear? Aliases, references are probably something that may be confusing for a lot of people. So who's okay with this concept of names and having them refer to different things? Anybody good?
You can say A equals B.
Yeah.
And then later on you say, where did B come from?
Uh-huh. Well, it's actually kind of subtle because numbers in Python are actually atomic. So if I do A equals 1, B equals 1, C equals 1, D equals 1, all of those are actually literally referring to the same number 1. Yeah, when I make integers, I don't actually copy them. They all refer to the same thing. So it's kind of subtle. But if you do A plus equals 1, you've now changed A. A used to refer to 1. Now it refers to A plus equals 1. It refers to 2. So A is going to refer to something else. But B is still going to point to the same thing. That sort of makes sense? But yeah, think about whenever the equals, what the equals does is the equals changes what that name refers to. It doesn't actually change the thing itself, but it just retargets what that name refers to. And I think that's really the best way to think about it is when you do A equals something, B equals something, all you're doing is you're retargeting what that name refers to. You're not actually mutating the thing it refers to. Yeah, okay. Okay. And then our pizza is here. So let's see if I can zip through this. How many more do I have on sequences? Okay, we talked about sorting lists and we have lists of lists. Okay, so that's about all I have for sequences now. Our next thing is we're going to start talking about dictionaries, which is our next most sophisticated collection. So now you guys are experts at dealing with basic atomic types. You're experts at dealing with ordered sequences. So now we'll get into the next level of sophistication of what these things are called is these are called collection types that I'm talking about here. So when we look at a dictionary is probably one of the most commonly used data types that you will encounter in CompuCell. So what exactly is a dictionary? So dictionary, that's the main way that users have of attaching things to CompuCell objects, okay? And so let's go over a motivating example. So let's say we are tasked with mapping a list of student names to a set of grades and a course. Okay, so one way of associating these things will be to create three separate lists. Each of them must have the same length. And whenever we update them, we need to do a lot of bookkeeping to keep track of the index and other stuff. But when we look here, if we wanted to update this, let's just say if we wanted to update another list that has a grade with the list that has their name, well, we would first need to grab the index of the name and then modify the list by that index. And it's messy, it's cumbersome, and it's very inefficient. So we need to step back and ask ourselves, what exactly are we doing here? Well, we are fundamentally associating a name with stuff, okay? That is the basic concept of what dictionaries allow you to do, is they allow you to associate a name with stuff in a very high level sort of way. Okay. So I have keys, values, okay. Not interesting, okay. So how we actually create a dictionary in Python is we use the squiggle brackets, the squiggle braces syntax, and we use the colon operator. So what we do here is if we want to create an empty dictionary, it's simply just a empty braces. But if we want to associate things, we create it as in key, colon, or actually semicolon, value, key, semicolon, value, dot, dot, dot. As many as you'd like, okay? Your keys will almost always be strings. If you wanted to get fancy, you can use other kinds of objects as keys, such as numbers, or you could use numbers or other sort of things. The one catch is that all of your keys have to be the same type. So I don't believe you can create a dictionary that has a mixture of strings and other things as keys. I think all the keys have to be the same type. Okay. So we can evaluate things. We can look things up in a dictionary very similarly to how we look things up in a list, where we use the square brackets to access information. So basically, the only difference conceptually is Conceptually, a list, your keys are sequential integers starting at 0. So in a list, you do list index 0, list index 1, 2, 3, yada, yada, yada. But what if you didn't want them in order? Or what if you wanted to use names to look things up? Well, that's why we use a dictionary. It's, another word is called an associative container because we associate keys to values. Okay. Okay. So operations on dictionaries. So much like a list, adding an entry, it's syntactically, adding an entry to a list is identical to adding an item to a list, where we simply do dictionary name, key name, assignment, stuff. Okay. To test if a dictionary has a key, we use the in operator. So I'll go ahead and I'll demonstrate this. So we'll have let's look at a list. So B is a list of 1, 2, 3. So we can do 1 in B. So the in operator checks if that object is in a container. So 1 is in B, 35 or 45 in B, false. Okay. So we can make a dictionary like D equals okay. And now we have our dictionary. So let's see. So we have 1 in D. Yeah. But so the in operator checks on the keys, not the objects, or not the values. Okay. So we can that's how we can test if a dictionary has a specific key. What if we wanted to look at the individual keys and values? Okay. So we can look at the methods that are attached to that dictionary. So we can do dir, and that gives us a bunch of things. Okay. That gives items, keys, things. Okay. So we have 2 really important methods that are attached to the dictionary object. And those ones happens to be the items and keys, okay? A dot keys. Oh, D. So if I call the keys method attached to the dictionary, that gives me back a set of all the key values. If I do D dot items, that gives me back the actual pairs of items in there. Okay. Let's do D dot. Let's see what else we got. We got from items, keys, values. Okay, let's see what values does. Those are my values, okay. So, 3 important things to remember on dictionaries: keys, items, and values. You probably won't use items hugely much because they just give you the key value pairs. It's probably more common to look at the individual values and keys, okay. So we can do, let's see, 1 in so 1 is stored in my values. 1 in keys. That's false. Oops. 1. Yeah. What am I doing? 1 in. Yeah. Why doesn't this work? Okay. Let's do d dot items. So, but what we can do is we can create a tuple in. That's true. So that pair of A1 is in my items. So if I explicitly wanted to check if my dictionary has a specific mapping, then I could do something like this. Okay. So keys, values, okay. Okay. So another couple things to remember is we can have duplicate values in here. So we can do something like D equals okay. So we have this dictionary where we have 3 separate keys in here, and they all refer to the same value. I mean, it's good to have that. But what if I try to do this? D dot, and I'll do tab, keys, pop item, values, okay. So what if I wanted to do, actually, we should be able to do, let's see, D plus, oh, I can't do that, okay. So we can remove items based on the key also, okay. But what if I wanted to do this? D equals what do you suppose will happen here if I wanted to store the same key in there twice? Well, it tried to, but what actually happened here is it went to build this dictionary. And effectively, when I issue something like this, it effectively does this. D equals empty one. Then I did D equals 1, D So that's why I got this funny looking thing where D only has one value in there. Because the first key value pair, it got inserted in there just fine, but then the next key value pair overwrote the first one. So my sets of keys by definition have to be unique. Okay. Okay. So our immutable, we cannot change the keys once they're inserted. That's why strings are most commonly used for as keys. Okay. And there's no order. So when actually store things in an actual dictionary, internally, I mean the ordering of keys internally, it's not actually defined. So you cannot count on the order of keys, but you just have to treat it as a set. So let's look at a difference between lists and dictionaries. So they're both conceptually very, very similar. They're both fundamentally containers for storing sets of stuff. So lists are an ordered sequence of stuff. Lists have to be addressed by integers from 0 to n. 0, 1, 2, 3, 4. That's how I access elements out of a list. Dictionaries, I access them via keys. So I can have dictionary index A, dictionary index B, dictionary index potato, whatever I want my keys to be. And my ordering of my keys do not have to be unique. So dictionaries are a convenient way of storing key value pairs. They are a convenient way of storing lists of numbers where I do not want my numbers to go in order. So if I want to do something like this, so I could do D equals, and I could do D 35 equals 1, D okay. So you see now D is a mapping of numbers to numbers. I could do D 34, gives me a 1 back. But I do D index something else, that is going to raise an error saying, hey, that key is not in my list. Now, we'll go over dealing with errors here probably about a half hour or so. So one way of dealing with this error is actually do a try catch, and I will cover that here in about a half hour. But if you want to avoid this error, how would I avoid this error? What question could I ask of my dictionary? I could do 657 in D. That's not in there. But I believe 34 in D. That is. Okay. So I can ask that question before trying that operation. Okay. Oh. That leads me to the next step. So no ordering. Index has to be an integer and list. Okay. Well, now, that sort of should be a nice segue into branching. Okay. So now, computers wouldn't be terribly useful if the only thing we could do is perform calculations and store stuff in dictionaries. We need to be able to tell a computer to actually perform some task based on conditions. So we need to start being able to way of teaching the machine rules and logic to perform some useful task. And that's where we get into this idea of control flow and branching. So what we have here is we can write an if expression. If some condition, colon, a series of expressions, okay? So this is where we get to one of the two most confusing, they're probably the two most confusing aspects of Python, is that to represent this is called a block. So what a block is a block is a set of expressions that will be executed in a row. To represent a block, Python delineates those via indentation. So you make a statement, semicolon, all of the following expressions that are lined up at the same column are treated as a block. I mean, it's kind of a weird Fortran idea that they borrowed. The other incredibly annoying thing is when you get to writing classes, everything has to have a self in there. So so that's just the way it is. Okay. So let's do a couple conditions here. So we want to, this is how we write a block. So we can do if true, let's make sure I'm having that right. Close these guys. So if condition, semicolon, expressions. So let's just do this. If true, print yeah, okay. So if false, okay. So if true, if false, okay. So now we're going to actually probably switch over to using the actual window here, because when we start writing indented blocks and so forth, it's probably more convenient to use the actual script window here. So let's go through a couple examples. So we got if condition elif. So let's go ahead and do that. So we can do if true, print true, else not true. And run this guy. Okay, so we printed true. Okay, we can do all sorts of stuff. If 1 is greater than 0. Now we start getting into logic operations. That's true. If 1 less than 0. That's not true. So you see how we have these various different branches of stuff. So if, branch, else, branch. So we have, you can do an if. So a couple flavors of this. You can do just an if. You can do an if by itself. And we can do print more stuff. Okay. So you see that the statements following that block will be executed no matter what. So you can write, this will run no matter what. Okay. And that's how I added a comment. Is comments, I indicated comments via the hash mark at the beginning of a line. That's a comment. Okay. So those are never executed. Okay. Yeah. So condition blocks, they have to be that indentation there. So once that indentation block is done, then this is considered the same block as the parent one. Yeah. It's just something you have to get used to. Yeah, correct. I think in virtually every other language, you use some sort of parenthesis, or in Pascal, you use square brackets. Every language has some way of indicating it. The only two that I'm aware of that use indentation are Fortran and Python. But I thought he had like the C thing for the Fortran 77. Yeah, comments have to be a certain column. Oh, okay. Okay, they probably changed it in 90. Okay. Okay, so that's basically it's just the way it is. Okay. So that's why we have to deal with this thing called indentation. Okay. So let's do a little bit of an example here. Let's go ahead and just copy this whole thing here. I don't think I can copy this. No, I can't copy it. Okay. So that's why I'll move this over here, and I'll have my editor here. I'll type this in. Okay. Well, let me go ahead and run a little example here. So this example will use input, and we'll use conditions. Okay. So let's do x equals float input x. Okay. Actually, I don't even need to. Yeah, I do. Okay. Okay. Does not equal 0. Print okay. So what am I doing here? Elif print so let's take a look at what happened. So I'm going to run my little script here. Okay. So this script will run. It'll execute the input statement. That input statement will print out on my console and prompt the user for a number for X. That input will return that string. That string will then be passed to float, where float will convert that to a floating point number. Same thing for Y. So now we get to our first condition. We check if X and Y are equal. Okay. If they are, then we just print they're equal. Now we do a nested condition, okay? So if Y is not equal to 0, okay, then we can print out, then we can perform a division here. We can do X over Y is, and actually perform that division right here as an argument to my print function. Then okay, so we're done with this block. Then we go back up to the previous block. Then we go back up to the previous one. Then we execute the next one. We ask the question, is X less than Y? Print that out. Otherwise, there is no other option. So if they're not equal and it's not less than, then the only other option remaining is it has to be smaller. Let's run this guy. Okay. So let's do X. Oops. 45. Enter. 10. Okay. So Y is indeed smaller than 45. Okay. Let's add another little thing here. So print okay. So I added that divide there. Okay. So let's do an X, 1, Y is 0. What happened? What happened here? I did not check if Y is 0. And I just went ahead and executed a division, and I got a division by 0 error, which is not great. Okay, so that's the basic idea for conditions. Pretty standard syntax, well, except for the indentation blocks. Okay. So moving on. So probably one of the most common things you will do is you will iterate over items in a sequence. Okay. So remember we had the in, I introduced in, where I think I had A equals and I did 1 in A. Okay. So the in keyword in Python, it not only lets you check if an item belongs in a collection, but it's also a way of iterating over all the items in a collection. So that's how I can do for I in a print So this is how I iterate over, this is how I do something with all the items in a set or a container of some sort. I do for my loop variable name in collection name. That's how I do. Okay. That is usually almost always the way you want to approach looking or doing something with items in a collection. You want to do for name in set. Okay. Okay. So this is a code example where I'm going to skip this example actually. All right. So let's do a little exercise. So I'm going to ask you to do a little exercise where I want you to ask the question, what are common letters between two strings? So why don't you guys just go ahead and type this in and see what happens. Okay. Now, as you guys are typing this in, we are going to extend this as a little do-it-yourself exercise where once you have this working, of actually printing out the common letters and uncommon letters, I would like you to extend this example and add two lists here. So I would like you to add, call it common and uncommon as two lists. And when we encounter the common and uncommon letters, add those to the appropriate list. So all of you have the little green sheet in front of you. Knowing how to look stuff up is probably one of the most useful techniques or tools you can learn. Uh-huh. It doesn't matter. No, it doesn't matter. Why is it? Okay, so in that case, yes, you're right. A comma or a plus would result in the same thing. But let's look at a subtle difference between how it actually works. When we have a plus here, what we're doing is we have a string and then a character. We are taking that string and that character and we're concatenating them together to another list, and then, or actually another string, and that concatenated string will be then passed to the print function where it will then just print it out. The other way, I'm keeping them separate, and then print gets both a string and a character, and then print itself will take care of going over every character in the string and dumping it out, and going to the next argument and dumping that out. So result-wise, it's the same thing. How it actually gets, how it works behind the scenes is subtly different. Yeah. Yeah, we're actually not going to get to set differences. Yeah. But yeah, doing for yeah, yes, sets are certainly the most more appropriate way of doing this. But yeah, I don't think in CompuCell you use sets for anything though. Okay, so how are you guys doing? Okay. So how you guys doing? So, take a look. You have a string and you're not connecting it with a plus. Yeah. So you're just doing a string and a char. You need to add them together.
Here,
Yeah.
in this space.
No.
Oh, here, okay.
Yeah.
So yours is this one.
Yeah. Oh, yeah. I guess. Okay. Okay. So who's got some working? Anybody? Uh-huh. Oh, great. Okay. Oh, goody. So common list that append. Okay, so that's your common list. Okay. Now something interesting is going to happen because when you add two characters together, that's actually going to make a string, right? So what you need to do, yeah. So instead of adding them together, you need to do append twice. Yeah. Hey. Window. What? Oh, you want the spider open. Okay. Okay. Okay, so let's go ahead. I'll go ahead and do that one for you guys. All right. So let's take a look at what I did here. So I went ahead and I did this little example. I started with the original code that I had for you guys. And then what I did is I simply just added 2 lists to here. And on the first one, because I know they're common, I simply append that char to common. And if they're uncommon, we know the characters are different. So I append them. Okay? So you guys see how it works? What's the issue here? The what? There are a lot of, there are a lot of common and uncommon letters. How could I check that list if that letter is already there before I add it again? In, I use in, yeah. So what I would do here to improve this, I mean, this does work. It is technically correct, but it's not super great. So what I could do, if char1 not in common, okay. Yeah. So that gives me a lot more of a concise result. See what I did? I checked my list to see if char1 is not in there. And only if it's not in there do I then append it. Similarly, with char1, oops, what did I do wrong? Who can catch my typo there?